Okay, let's look at the charge distribution here. Okay, these are conducting sphere, so when the positive rod is here, let's imagine that they have both 4 positive charges and 4 electrons each. So the positive charges cannot move. So this positive rod, it will attract all the electrons. So the electrons in this sphere, it will travel across this sphere to form up here. So all the electrons that are movable, they will be concentrated here. Then after that, you separate these two matter sphere. This matter sphere will have more electrons than positive charges, so this will be negatively charged. And this matter sphere here has less electrons than positive charges, so it will become positively charged. So the answer should be D. Okay, let's look at the formula for the resistance of a wire. Okay, the formula goes like this: resistivity multiplied by the length divided by the cross-sectional area. So that means the resistance is directly proportional to the length of the wire. So the longer the length, the higher the resistance. And the resistance is inversely proportional to the area. That means the larger the cross-sectional area, the smaller the resistance. So in this case, we have a filament of length X. It is thicker and shorter. So thicker and shorter means that the resistance is going to be much lower. So the larger resistance here, right, it should be Y. And since X has got a lower resistance, the current should be higher according to the formula. I is equal to V over R. Length X has got a smaller resistance, so based on this formula, the current must be higher, so the length will be brighter. So in this case, it will be just X. The answer is B. Okay, for this question, right, the keyword is bulb. Okay, for a filament light bulb, it is non-ohmic. So as the current increases, the temperature will increase and the resistance is going to increase. So to find out which of the options, right, is actually the reading for the torch bulb, we just calculate the resistance for all the values and we see which options, right, exhibit a change in the resistance, and that must be the reading. Okay, let's do it for option A. Take voltage divided by current. This one we will get 1 over 6. Okay, for this we get 2 over 12. Simplify it, 1 over 6. 3 over 18, we get 1 over 6. So this is not the answer because the resistance value is stayed constant. Okay, option B, we have 1 over 12, 1 over 25 here, and 2 over 25, and 3 over 60. Simplify it, we will get 1 over 20. Okay, we find that the resistance value actually increases. Okay, so this is the answer. And let's do it for option C and D. Okay, we have 1 over 20, 2 over 40, so we get 1 over 20. 3 over 60, we also get 1 over 20. So this one, the resistance value remain constant, is an ohmic conductor. And option D, we have 1 over 10, 1 over 10 here as well. 3 over 30, we get 1 over 10. So the resistance remain constant as well. So the answer is B. Okay, we have two batteries. There are 2 volts. They are connected in parallel and it is used to power up a resistor here. So when you put a voltmeter here, you are basically measuring the voltage of the battery. So in this case, it's 2 volt. Okay, when the 2 volts batteries, they are connected in parallel, the voltage stays the same as 2 volt. Okay, so for V, it's going to register a reading of 2 volt. And for current I1 and I2, right, because there's only one path for the current to flow, the voltmeter is very high in resistance, so no current will flow through. So all the current will flow through the resistor. Then after that, it will come back here then it will form I2 and it will come back to the battery. So I1 and I2, they are the same. So we look at the option. Voltmeter reading is 2 volt. I1 equal to I2. So the answer should be C. When the switch is open, the ammeter reads 0.5 ampere. That means 0.5 ampere flows through the 6 watt light bulb. Okay, so when the switch is being closed, we can find out what is the current here. Current is equal to power divided by voltage, and the power is 12. The voltage is 12 also. So the current that passes through, it will be 1 ampere. So now the reading of the ammeter, it should be 1 ampere plus 0.5. We will get 1.5 ampere. Answer C.